I can't help it now. No? Um, Alsona, I'm putting up the YouTube link on the chat. Just take it and post it, please. Hello. Yeah, it is on the chat. Alsona.
Yes, ma'am. Yes, ma'am. I'm waiting for your.
Just take it and post it, please.
Yes, ma'am. Yes, ma'am.
Hello. Yeah, it is on the chat. Okay, sir, we'll just begin in a short while. Sorry for this trouble. I tried something new and it didn't work out.
Ma'am, now actually the thing is we had put the previous link and everyone has joined with that. So it will take us some time to put the link again. So
Yeah, just put it. Yeah, just
yeah,
put it.
yeah.
Wait for a few minutes. Yeah.
Yes, ma'am. Uh, Ma'am, and looks like Risal is also not there in the meeting. Risal and Rachel.
What happened? But
I'm not sure what happened.
okay, okay. I'll just check. You put the link in the.
Yes, ma'am.
So, ma'am, we have to leave this meeting.
No, no, no.
No,
Here.
only for the YouTube participants, not for the Zoom.
Okay, we can start this anyway. We are recording it, so the YouTube participants will be able to view it, right?
No, ma'am, they'll not be able to see it now.
Okay, okay.
So just give me a few minutes.
Yes, no problem.
Ma'am, where have you sent the new
Chat,
YouTube link?
the chat it is there. You can see it also now.
No, ma'am, could you just message me or the link on WhatsApp also?
What to message on WhatsApp now? God. Yeah. Just.
Hello. YouTube and Zoom will be the same.
You are streaming on YouTube also now. I can see you.
Uh, okay, okay, I'll just check.
Yeah, so if we can begin, no, they can see it, I'm saying.
Okay, ma'am, if they can see it, then we can start.
Yeah, 1 minute. I'll just send it directly on the groups only.
Yes, ma'am, please. Clarice, are you there?
Yes, also na.
Clarice, could you just disable the chat on all our WhatsApp groups?
Yes,
Vinny
okay.
ma'am is putting the new link, so yeah.
The Blaze is asking me, that he's having a problem also now. What to do now?
Ma'am, now actually already all 100 participants are there and I don't think now father will be able to join in.
Okay.
Because even Risal and Rachel are not there in the meeting. Somehow they got logged off.
Yes, Father, we are trying to solve the problem. Yes. Okay, sorry. Okay. Yes, yes. Okay. We'll try to put you in. Just see, Father. I've got another problem here. Okay, we will start. 1 second. Why that other one didn't work, yeah? You can see the YouTube now. Let's see. Yeah. Okay, so let us begin. Good evening, participants. Um, Sorry for this delay. I tried out something new of live streaming it through a customized channel, but maybe I have to do some more experiments on that. So now to begin with, I would request Dr. Susama Samuel, our principal, to start with a few encouraging words. Ma'am. Ma'am, you're there?
Yeah.
Yes, ma'am.
Hello. Yeah. Good afternoon, everybody.
Good afternoon.
Manager of our institute, Father Blaise D'Souza, esteemed resource persons, and all participants. A warm welcome from St. Xavier's Institute of Education to this mathematics webinar series on strategies and solutions for boosting mathematics learning. This webinar series is an initiative of Mathematics Pedagogy Unit of our institute under faculty in charge Dr. Sebastian, Associate Professor, and her team of mathematics students. The objective of this webinar is to boost mathematics education, that is mathematics teaching as well as mathematics learning, considering the significance of mathematics as a subject, as well as the other side, the mental block and mathematics phobia of our students towards this subject and how to overcome it, and how to develop interest in mathematics teaching and learning. Today, we have two eminent personalities from Tata Institute of Fundamental Research, Dr. K. Subrahmanyam sir and Dr. Shweta Naik madam. I welcome both personalities towards this webinar. Dr. Subrahmanyam sir is going to speak on a prerequisite for constructivist teaching, listening to students thinking, and Dr. Shweta madam will share with us Homi Baba Center for Science Education's mathematics activities for enrichment and professional development of teachers. It is going to be a double treat today, and today is all about mathematics. All the best to resource persons, an enjoyable and enriching session to all participants. Over to Dr. Vinny.
Thank you, ma'am. Participants, you all are please requested to keep your mics muted so that we can have a smooth program. Unfortunately, Dave is not part of this program because he tried to join in and he was not able to join in. So I'm just addressing him in absentia. Respected Father Blaise D'Souza, manager, Dr. Susama Samuel, our principal, SXI colleagues, our esteemed resource persons, SXI students, and our dear participants for today's mathematics webinar series 2 on strategies and solutions for boosting mathematics learning. I trust and pray that all of you are safe during this pandemic. We are truly humbled by the huge response for this webinar series. This series was started with the hope that SXI, through its mathematics pedagogy unit, could bring some positive changes in mathematics teaching learning at all levels of education, just spoken by Dr. Susama Samuel. We are so happy with the valuable feedback given to us by our participants for our last webinar. In order to see the changes happening through these webinars and also to learn from the participants' experience, we request the participants to share your innovations with us through a 1-minute video, which we, with your permission, will upload on our YouTube channel, Mathematics Learning Channel, for the benefit of all those who are interested in mathematics teaching learning. This initiative must not turn into a routine monthly activity, so we urge our participants to write your thoughts regarding mathematics teaching learning on our email ID sxiemathwebinar@gmail.com. I sincerely thank our resource persons for today and our student coordinators, Rizal and Alsona, who are also our co-hosts for this evening, and also Rachel and Clarice. Welcome all once again for this webinar. We've already wasted some time, so without much delay, I request Alsona to introduce our first speaker of the day, Dr. Subramaniam.
Thank you, Winnie ma'am. Good evening, everyone. We are honored to have with us Dr. K. Subramaniam as a resource person for today. Dr. K. Subramaniam is Professor and Center Director of the Homi Bhabha Center for Science Education, Tata Institute of Fundamental Research in Mumbai, India. Sir's main area of work for the last 2 decades through research and teacher professional development workshops is the improvement of the learning and teaching of school mathematics. Sir completed his B.Tech in Aeronautical Engineering in 1984 from Indian Institute of Technology, Madras. Thereafter, Sir completed his Masters in Philosophy in 1995 from University of Bombay. Sir has also completed his PhD in Philosophy in 1992 from Indian Institute of Technology, Bombay. Sir has diligently worked to develop curricular and co-curricular teaching materials, teacher training, and teaching students mathematics at school level. Sir has also conducted research in domain of cognitive aspects of mathematics learning, mental representations in reasoning and problem solving. Through his lectures, exhibitions, and books, including some on history of science and mathematics, Sir has strived for popularization of science and mathematics. Sir has given his valuable contribution to develop various resources for teachers like training manuals, real-life geometrical examples, a video module on assessment in the maths classroom covering the topics of teaching a mathematical procedure, explaining a concept, using teaching aids, teaching through questioning, etc. Sir has also contributed in various books, journals, proceedings, expository writings, internal and technical reports, and the list goes on. Dr. Subramaniam was also part of our Sxie College internal quality assurance cell, and we truly acknowledge Sir's contribution in enhancing the quality of our programs. We are extremely honored to have such an experienced resource person with us today. Once again, we heartily welcome you, sir.
Thank you very much. Should I start now?
Yes, sir, you may start with your session.
Thank you for those nice words and the kind introduction, Alsana. And thank you so much to Dr. Sebastian, Dr. Samuel, the D'Souza for giving me this opportunity to be with all of you today. It's a great pleasure and an honor to be here. And this is something talking to teachers, student teachers, even students and so on is something that I really enjoy. Of course, I wish we could have all been in the beautiful campus of St. Xavier's College, face to face and sharing the same space. But these are unusual and strange times, so at least we are able to meet online and have a chat. I'm going to really I was looking forward to this, and I'm sure all of you will also enjoy this evening with a talk by me and Dr. Shweta Naik. So before I start, I'd just like to say that please feel free to ask questions. If we were in the same room, I'd have seen you all raising your hand or seen the expressions on your faces. I'd have been able to adjust what I'm saying. But now I can't do that. We are all only on the screen. So I request the student coordinators, Alsana, others to let me know if there's, please interrupt me if there's any question you think we need to address. At the end, that's also fine. But please don't hesitate. If something needs to be clarified, I'm quite happy to do that right away. So let me begin my talk. Okay, can you all see my screen? Yes, and you can hear
Yes, sir.
me also.
Yes, sir. Yes. Yeah. Yes, sir.
Yeah. Okay. Do I need to speak more loudly, or am I audible and clear?
No, sir, you're audible and clear.
Okay. Thank you. So that's the title of my talk, and a prerequisite for constructivist teaching is listening to students' thinking. Of course, I'm not sure if you can see the entire screen. Maybe you can do some adjustments so that you can see the screen without the videos interfering. Okay. So what I'm going to talk about today is listening to students' thinking. And that's really the essence of what we call constructivist teaching or responsive teaching or student-centered teaching. All of these mean more or less the same things. And it's not teaching where you pre-plan, there is a scripted lesson which you come and deliver, and the students can either take it or leave it. It's not of that sort. It is rather something in which you're adapting and listening to students and responding to them, and thereby supporting their learning. And on the whole, this is a much more effective way of teaching. So that's what we will talk about. And I'll be drawing on our experiences in research and classroom teaching and learning, on our own experiences, also on some of the literature which is available. And of course, it's not particularly tailored to our current situation, where I think many of you are doing online teaching, keeping contact with the students over the distance and so on. But some of the same things do apply. Listening to students' thinking is important in any context, and some of these will also apply there, although it's mainly drawn from the experiences of regular classroom teaching. Okay, so this is an overview of my talk. I'll spend time talking about what I mean by thinking, and that'll be my first example. This example won't be from mathematics, it's from our daily experience, you could say maybe related to science. Then I will talk about, I'll ask this question, do students think in the classroom? And I'll give an example of what I think is an example of students thinking, and what it's involved in noticing such thinking. So in particular, I'll talk about the sort of knowledge that teachers need in order to notice students' mathematical thinking in the classroom. Then I'll talk about, students also make a lot of errors. Now, does that mean that they're not thinking when they make these mistakes, they're not paying attention? Not necessarily. Sometimes good thinking can also lead children to make what we consider errors, different from standard mathematics. And that's actually productive and helpful in teaching and learning. And so I'm going to also look at that example. That will be my third example. The third example is has to do with the topic of measuring length. My second example is on decimal numbers, and the first example is from our daily astronomical experiences. And of course, I'll end the talk by saying a little more, and depending on the time. Okay, so that's my first theme or first question, what is thinking? And I'd like to begin by giving an example. So just to check, am I still audible? And can you see the screen?
Yes, sir.
Yes, sir.
Yeah. So in between, I'll also request Dr. Sebastian to launch the polls. I hope you are ready with those polls.
Yes, sure, sir.
Okay. So here is a picture. I hope all of you can see the picture. What can you see in the picture? Can you see the moon? It's the crescent moon. And typically you see it in the evening or in the morning, just above the horizon. Uh, and there it is. So this is one picture of the crescent moon, picture one. And this is another picture, picture two. Now, I have a question for you. And the question is, which is closer to what we actually see? So that's your poll one. Which picture, picture one or picture two, is actually closer to? So let me show those. I think let me drag this poll window to one side. And so you can do that also. Let me show you again picture one, sorry, picture one and picture two. And so which picture is closer to what you actually see? So I'm giving you about 30 seconds to select one. So picture one is closer to what we see, or picture two is closer to what we see.
So can you see the results?
Yes, I can see the results. I suppose that's the final result. And 71% have picked picture one. That's very, very interesting. And 29% have picked picture two. So, so what's really the case? So now if you see, it's actually what you see from Mumbai and from Maharashtra and from most of India, or rather the tropical latitudes, is actually closer to picture two. And
Yes.
so it's a bit like this. Maybe it's a bit inclined, but more closer to that horizontal thing than the moon standing up. But we all remember, pictures we have seen of fairy tales or Chanda Mama or whatever. And then I think even in movies. So you remember the moon sort of standing up, which is not the case in the tropical latitudes. Yes, it's like that when you go to the higher latitudes, when you go to Europe, Northern Europe, and so on, it'll be much more like that. And why is that? And that's the reason why I gave this example, because it has something to do with historical fact from the history of science, and it's really fascinating. Because if you look at the moon, the crescent moon, and if you draw that arrow which sort of goes through the center, through the middle of that shape, pointing outward, that is on the curved face of the moon, and you draw that arrow, you will see that arrow points to the position of the sun in the sky. So of course you can't see the sun because the sun is just set, but the arrow exactly shows the actual position of the sky, of the sun, just below the horizon. And this is always the case. So when you take the crescent moon, the half moon, what's called the gibbous moon, which is more than half, if you take the outer curve, the convex curved surface, and draw an arrow through the center of it, it will always point to the position of the sun in the sky. And that's fascinating. And that's something that you don't usually notice. And in the tropical latitudes, of course, the sun is oriented like that. But in the northern latitudes, the sun follows a more angled path, and which is why the moon is more tilted towards the vertical. Of course, we don't observe that. And what we observe, in fact, what people have observed from ancient times, is the dramatic change in shape of the moon. How is it that the moon changes, which is so prominent in the sky, changes shape from being a thin crescent to a half moon to three quarters to full? And this happens just over a few days. And it's quite mysterious. And people thought of all sorts of explanations for them. Many people thought that somebody is eating the moon and then spitting it out. Of course, many people think that it's, those who have learned a bit of astronomy, modern astronomy, think that it's the shadow of the earth which is falling on the moon, which is also not quite correct. It's not the shadow of the earth, which is correct during the lunar eclipse, but during the change in shape of the moon, which we call the phases of the moon, is simply because a part of the moon is lit by the sun and it's not turned towards us. We are watching the moon from a side or from the back or more from the back. And so we can only see a part of the surface of the moon which is lit by the sun. And that's really what the arrow shows, because the sun is lighting from that direction and the moon is turned away towards the sun. The sun is much further away. And so it's facing, so you can say that the bright side of the moon is actually facing the sun. And this is always true. We never notice it, of course. But somebody did notice it, and this was a Greek philosopher in Athens. At least that's the record we have. Maybe many others noticed it, including India. But this is what is recorded, that a philosopher in Athens called Anaxagoras, around 400 BC, noticed this. And he said that why is it that the moon's face, the bright face of the moon, is always pointing in the direction of the sun? He wondered about it. And he came up with a simple explanation. He says it's because the moon shines by the reflected light of the sun. And that explained completely why the moon actually changes shape from day to day. So you can imagine that something that you cannot quite see, but through the imagination you arrive at the correct explanation. I think I really like this example. I think it's a brilliant example of thinking. And so let's look at what elements of thinking are involved in this example. One is observing, noticing a pattern. Of course, we won't observe if you're not curious. And the nice thing is that children, students, and so on are naturally curious. So they're always looking, observing things, noticing, wondering, and so on. And so this is also likely to happen in our classrooms, and we should encourage it. So one part of thinking is just observing, and what drives that is curiosity. But observing alone is not enough. It's to describe the pattern, to precisely capture what it is that you're observing. Because once you capture the pattern, you articulate it through language. Now that helps enormously in carrying forward the process of thinking. So articulating. So we articulated by saying that the bright face of the moon is always pointed in the direction of the sun. Of course, then you ask, imagine what might explain this. You know, this is a very peculiar pattern. It is a strange pattern, but is there something which will explain it in a very simple way? And yes, it's simply explained by saying that the moon just shines by reflection. And so, of course, imagining alone is not enough. You must check the facts. You must check every day, the next day, and so on, and see if the what you've thought of, your hypothesis or your explanation of the phenomenon is correct or wrong, and you test it. So this is a part of coming up with the explanation and checking the explanation, both of which we could say is reasoning. So thinking has all of these elements, and let me again summarize those. So there is an element of curiosity. There's articulation or speaking it out in language. There's some imagination involved in coming up with an explanation, coming up with a model which removes the mystery surrounding a phenomenon. And then, of course, imagination can run quite wild. You must check your imagination by reasoning and seeing whether what you have come up with is actually holds true or not, by checking it with facts, by more observations, or perhaps doing some experiments and so on. Of course, I have not outlined everything or described everything that is involved in thinking. This is not a philosophical essay. There are many other aspects to thinking: asking a question, probing for unstated assumptions, examining the concepts one uses, many things that one could say further. But for our purposes for today, this is really enough. And let me continue. Okay, so this is a question that I asked now. Do students think in the classroom? Maybe I should have put this in the poll, but feel free to express yourself in the chat room what your views are on whether students think in the classroom and what your own experience has been, and so on. Okay. So this is an example that I have from the classroom. Okay. This is an example from class lesson for class 6, taught by a teacher in one of the schools in Mumbai. And this example is taken from the work of Shweta, who is my PhD student, and I'm thankful to her. It's indeed a lovely example, and both of us, I think, have learned quite a bit by reflecting on this example. So here is, the lesson is on decimal numbers, and the teacher is explaining what a decimal number is. And that's the example she has on the board. And she has written 683.12 on the board, which is indeed a decimal number. And she's beginning by explaining that the decimal number has place values which are more than or different from whole numbers. And I hope you can see my mouse. She's saying that, okay, you have the ones place, the tens place, the hundreds place, and this is the whole number part. And you have the decimal part, and you have the tenths place. So there's the tens here and the tenths, and she emphasizes the difference in pronunciation, the difference in spelling. So the tenths and the tenths, and you have the hundreds here and the hundredths. So you could say, so she's making this correspondence, and then she's explaining and introducing the students to this place value in decimal numbers. Of course, the students are very curious, and they are thinking in the classroom. And do you have any idea what the students might ask? Something pops up in the student's mind. And so let's see what the students ask. So there's a student's question, and actually this lesson was observed over 2 years, 2 consecutive years. And in both years, the students asked the same question. It's very interesting. So what happened in year 1? So as soon as the student introduces this place values and says tens, tenths, hundreds and hundredths and so on, one student asks, what about ones or one-eths? And another student says, one-eths nahi hota, chal. And the teacher appears to ignore and moves ahead. So this is the question asked by the student. Interestingly, in year 2, you have a similar episode. So exactly the same introduction is done by the teacher. And one student asks, ma'am, one-eths kyun nahi hota hai? And this time the teacher is responding in a very different way. And she poses the question back to the class. So this is called revoicing in some writings. So the teacher revoices what the student says. It's one of the techniques of getting children to discuss and to present someone's thinking. So the teacher says, Nikita is asking, why is one-eths not there? Another student says, ma'am, hota hai. One-eths hota hai. And then there's a discussion on why one-eths are not there. So this is a very interesting question. And it's something worth thinking about for us. It's not just an example of students thinking, but it's also an opportunity for us to think what exactly is going on in the student's mind, why they ask this question. Now, the interesting thing that I'd like to tell you is that Shikha, my student, she observed about 8 lessons. And in about 6 out of these 8 lessons, actually this question cropped up. So it seems to be a very common question. It's also something that we have read about in the literature. It's reported by others. So the interesting question is why this question is asked and why does this crop? So once again, to just recall the question, there's hundreds, tens, ones, tens and hundreds. And the student's question is, why is there no distinct place for one-eths? Why is one-eths missing? And our questions is, why are the students asking this? And is it important to respond in detail? Okay, now here is poll 2, and this is for you to respond. I hope you can still hear me and you can see the pool. So are there one-eths in a decimal number? So you can click. So are there one-eths or are there no one-eths? 30 seconds for you to click. I think this is taking a little more time. It's all right. You can take a risk. There's no harm. Okay. So no, and somebody says yes. That's very, very interesting because in some sense, I think both of these are correct. And so that's really interesting. So let's see what actually happens. So why are there no one-eths? This is what the students are actually asking. Now, in order for the teacher to deal with the student's question, firstly, I must say that the teacher must notice what the students are saying. Now, in order to even notice what the students are saying, one must have some inkling of what the students are thinking. So it's important to sort of see behind what the students say and get a window into the student's mind and the student's thinking. And that requires some specialized knowledge on the part of the teacher. And this has been written about in the literature. Many of you may be familiar with this phrase called
Sir,
pedagogical
please
content.
excuse me.
Yes?
Sir, please excuse me.
Yeah.
Sir, when you are talking on the screen, no, the participants are drawing some lines. It's called annotating. So,
Yes.
sir, you need to disable the annotations on your screen because I have disabled since your screen sharing.
I
You
see.
need to disable. So, sir, on top right, you can see more. If you click on more,
All right.
there will be a drop down,
Okay.
and
So,
on the top right, sir. So you can see more.
there's only my screen, so let me try to come up.
You have to stop sharing, sir. First, you stop sharing.
Okay, I'll stop sharing. All right.
Okay, so then
I go to,
so on the right, sir, on top there is more.
there is more. Is it okay? So let me.
So, sir, you have to disable the annotations because I have constantly put up messages on the chat, but the participants are still annotating.
Okay. So let me see more. Yes, there is more. And
Disable participant annotations, attendee annotations.
okay, I don't think I have that with me. So Zoom.
Okay, so participants, please refrain from annotating on the screen while the session is on. So you can continue.
Okay. All right. So let me
And share
share
your screen.
again. Okay. So we are back, and can you hear me?
Yes, sir.
Okay. So I was saying, so how do we notice the student's question? How do we make use of it in the teaching? And how do we respond to this? So all of this requires a particular kind of knowledge, which is specialized knowledge that teachers should have. So a little bit of my talk is also about this specialized knowledge. Some of you may be familiar with this term called pedagogical content knowledge, which is the sort of knowledge that teachers need to have, which is their own professional knowledge. So even if you're teaching mathematics, of course, you need to know the content, you need to know pedagogical techniques, etc. But there's something which is an amalgam, which is a sort of combination of content and pedagogy, which is about mathematics and about pedagogy. And that's what's called pedagogical content knowledge. So you could say my talk is also about pedagogical content knowledge, which is actually essential to do responsive teaching or constructivist teaching. Okay, so what is this knowledge? So this knowledge is partly about the way students think and partly about mathematics. All right, so now let me talk to you about both those parts. And remember that the question that the students are asking is, why are there no Punnets in the decimal number in the place values? Okay, so here is a picture, and you can see that what the teacher did when she presented this decimal number 683.12 is to talk about the place value. She said ones, and then she said tens, and just like there are tens, there are tenths to the right of the decimal place. And just like there are hundreds, there are hundredths to the right of the decimal place. So she's setting up a kind of correspondence between tens and tenths, between hundreds and hundredths. And you can see that what is implicitly cropping up is something like a mirror metaphor, you could say. And this mirror metaphor is immediately absorbed and noticed by the students. And so they make sense of it. And of course, so the question crops up that there is ones here and there's a mirror here, so there must be a ones. And so this is a legitimate question. And so this is part of what you could say the analysis of thinking. It's the mirror metaphor which is cropping up and which is inducing the students to, inducing this question to pop up in their minds. However, in order to respond to this, you also need to know a little bit of the mathematics of decimal numbers. And here is something quite interesting. And it also is an example of why mathematics is gives you deep insight, and it's can be very insightful, very powerful tools to explain concepts. So let me show you something of the mathematics. Now, if you look at the mathematics, you will see that I have used a device here, that is to use what we call the exponential notation to represent all these place values. I think many of you will be familiar with the exponential notation. For example, 10 is written as 10 to the power 1. That is the place value of this place. Hundreds is written as 10 to the power 2, which is the place value of this one. 1000 is written as 10 to the power 3, which is the place value of this position here. Now, when you go to the right, you have the tenths, which is 1 by 10, 1 over 10, which is written in exponential notation as 10 to the power minus 1. And the hundredths is written as 10 to the power minus 2. And the thousandth is written as 10 to the power minus 3. And now you see that actually the mirror, the location of the mirror is not at the decimal point, but it is at the units place. It's at the ones, because ones is written as 10 to the power 0. So that's really the center, and that's the focus. Every other place refers back to this position, this place value, or the units place. And so the notion of unit is actually very important. So when we talk about, so many meters, so many centimeters, etc., it's this place value which actually denotes that unit, and it's the units place. Every other place makes a reference back to that unit. So now let's say of the place much more clear. I think some of you need to mute unless you want to ask a question. If somebody needs to ask a question. Otherwise, I request others to mute. So we have here the location of the mirror is actually at the units place. And then you see that there's the tens and the tens, and there's the hundreds. And so the symmetry is nicely preserved, and the mathematics of it actually reveals what is the place of the symmetry. The decimal point, therefore, has no mathematical significance. It's merely to a convention to show which is the units place. It's just to the right of the units place, and that indicates which digit is actually sitting in the units place. That's you could even put the dot on top of the unit. It wouldn't really make a difference. Of course, in some languages, you know that the dot is replaced with a comma. Okay, so now I don't want to stop here. This is an analysis of the kind of knowledge that the teacher needs to notice students' thinking and to respond to it. But of course, how to respond to it can bring in some other elements of knowledge. And I want to take you to that because also to what actually happened in that particular lesson and how the teacher dealt with students' questions. Now, as I mentioned, the teacher did not deal with the student's question in the first year. In the second year, the teacher revoiced the question, posted back to the students. And the students had their own ways of explaining why there are no one-ins. And this is very interesting. Of course, I'll refer you to a paper. I don't think I put the reference there, but you can do a Google search. And this is a paper jointly written by Shweta and me. And you can refer that paper for details. But this is roughly what happened. So that one student said, ma'am, suppose there is a 1th place. Actually, it would be the same as 7 upon 1. And that's a very interesting argument. So let me explain what the student said and what the teacher actually accepted. And all the students did accept that as a common sort of argument that people agreed on. So what the teacher did, that let's assume there is 1th place. And suppose the digit 7 is sitting and occupying that 1th place. Now you know that this is sitting in the 10th place. So 1 is sitting in the 10th place, which means 1 upon 10 or 1 over 10. It's the fraction 1 by 10. 2 is sitting in the 100th place, which is the fraction 2 by 100 or 2 hundredths. So 2 upon 100. So in the same way, we should write 7 as 7 by 1 or 7 upon 1. Now you see that 7 upon 1 is not actually a fraction, but a whole number. So since it's a whole number, it cannot appear to the right of the decimal place. It should appear to the left. And in fact, 7 by 1 is the same as 7 ones or 7 units. And so there's no one its place because it's the same as the one its is the same as the ones. And this is very interesting, the argument, and I think it connects many things. It connects the decimal place values with the fraction notation, which is actually quite powerful. It tells you that ones and one-its are the same, and that's why we don't have a separate term like one-its. And that ones is actually the place of symmetry because it's what all the other place values are referring to. So this is a interesting thing, and I think quite a lot of thinking is going on in just asking this question, answering it, and dealing with this exam. So I hope that you're convinced in some way about that there are many instances where students are actually thinking in the classroom, and giving attention to that, responding to that can make the class very exciting. Of course, you can recall the elements of thinking. There's some imagination, there's some observation, noticing a pattern, articulating the pattern, coming up with an explanation, some reasoning. All of those elements are there in this thinking. Okay, now let me go to the next part of my talk, which is my next example, which is, see, students make errors, or they come up with what we call misconceptions or alternative conceptions. They're different from our standard mathematics. They're different from what we believe mathematically to be correct. And so we call them errors. And this is something worth pondering over, because why is it that students make errors? Does it mean that they don't think, they don't apply their minds? They are not, they somehow have spaced out and so on. And it's, in fact, often, not always, but often it's the case that students are actually thinking, and it's this very thinking and a kind of creative process that leads them to make or to develop or conceptions which are different from the standard conceptions and standard ideas. That's why they're called alternative concepts. And this is something very, very much at the heart of constructivist theories of learning, that the students actually actively construct their own concepts and conceptions based on their experiences. It's to account for their experience. And that can lead to concepts which are different from the standard concepts. And sometimes it can lead to what we call errors. And this is an interesting example. And so let's look at this. And the example is measurement of length using a scale. It's a rather simple concept. It's one of the simplest measurement concepts, and children learn it fairly early. And so we're going to look closely at students' responses and even students' errors in measuring length, and try to understand students' thinking. This is the example. And this example is taken from a study by Educational Initiatives, which is an educational organization. You can read more about it on the web. And this is a question which they asked to many, many students. And you can see the picture there. And there's a scale, there's a pencil which whose length is to be measured with the scale. And you can see it right next to the scale. And of course, the answer is clear to you. You can see that the length of the pencil is actually 5 centimeters. But the question posed to the students is, what is the length of the pencil? Is it 4 centimeters, 5 centimeters, 6, or 7? And now I'm going to ask this question to you, not to ask you what is the correct answer, which you all know, but to guess what young students, these are actually students of class 4, so very young, what young students are most likely to choose as the answer to this question. So that is your next poll. So you have an option. You can click on what you think. So what do you think is the most likely choice that young students will make out of these 4 options? 30 seconds. So I hope you can see the picture and you can see those numbers and the options. Okay, so very interesting. So I think this is, we really have a very interesting audience today. And many of you have guessed that the young students will choose 7 centimeters. And I must compliment you on that. And many others have also guessed the other responses. Okay, so let's look at what the actual responses are. And here is a distribution of the percentage. As you can see, 7 centimeter was the most common option. The correct option was only chosen by about 15. I think it's almost mirroring the results of our poll, Dr. Sebastian. I think you have a wonderful audience today.
Yes, sir.
And they've almost guessed it exactly. So, of course, some have chosen 6 centimeters, and very few have chosen option A, which is 4 centimeter. Now, it's interesting for you, and then it's interesting exercise for you to think about why students might be choosing these options and what is the reasoning behind these choices. Of course, so why do students make these errors? Can we learn something from them? Now, let me say a little bit about, you see, length measurement, as I mentioned, is a very simple concept. And students learn about it quite early. And many of you may be thinking, why are we making a big deal about this? Because about errors in measurement. Because anyway, as students grow older, we are talking about very young students. By the time they come to class 6, class 8, they're much older. They'll not be making any more errors. So why do we bother about this? So we can just proceed. These errors will go away, and let's not worry about these errors too much. Now, that's a fair point of view. But I'd like to share something interesting in response to that doubt you might have. And that is this graph, which is taken from the same study. And there's also a paper, the reference to that paper is given there. And let me walk you through this graph. So I told you that the question was shown to class 4 students, but the same question was also posed to class 6 students as well as class 8 students. So 3 different groups of students. The numbers are very large, 1,500 students, 1,800 and 1,500 here, very big numbers. So the statistically robust results, you can really believe in these results. And I'd also like to tell you that these students are from elite schools. They're actually from what were identified by most principals and so on in large metro cities, Delhi, Mumbai, Calcutta, Chennai, and so on, as in Bangalore, as the leading schools, the most reputed schools, and the English medium schools. And this was a question given as part of test to all those school students. And here are the results. Class 4 students, the green is the correct answer, which is 5 centimeter, and it's going up. Class 4, class 6 is nearly 40%, and class 8 is over 60%, which is very good. We should all feel happy. The students are doing very well, no problem. They're getting all the answers correct. And the 7 centimeter, which you all guessed young students will choose, yes, that is going down rapidly. From 40%, it's come down to 20% in class 6 and gone down to something like 5% in class 8, which is very good, as one would expect, nothing to worry. But I'd like to call your attention to this middle one, which is 6 centimeters, which is incorrect. Of course, it's not correct. But this error seems to be persistent. It's not going down with age. And you can see that it's remaining more or less constant, goes up slightly. So it's over 30%. So the question is, why is it that over 30% of class 8 students even choose this incorrect answer of 6 centimeters? And I'm going to now show you a video clip of students sort of responding to this question. And it's very interesting. Of course, the video is also taken from educational initiatives. It's linked to the study. And it's available on YouTube. The Education Initiatives as a channel. You can find it. And it's reproduced here with permission. So now let me show you this video clip. And so I'm going to stop sharing the screen here. And go to, I'm going to share the other one, which is the video. Here we are. Share, right? And I hope you can see the slide. And Can you see the picture of the pencil and the slide?
Yes, sir.
Yes, sir.
So I'm going to start playing the video. I hope you will all be able to hear the audio. Okay, so let me just pause and take you back a little bit to that example. And just call your attention. You see here, this example, of course, the pencil is again, the correct answer is 5 centimeter, which is fine. But the position is a little different from our earlier example. The pencil was placed at 2, from 2 and it went up to 7. But here the position is at 1 and it's going up to 6, which is a slightly, so the options are slightly different, doesn't matter. The ideas and the questions are the same. So don't worry too much about that difference. So now let's listen to the video clip. And as you can see that majority of the students actually chose the correct answer.
The pencil point is on C6 centimeter. That's why I think it is C, the correct answer. That when you show the scale here,
I hope you can all hear the audio.
Yes, sir.
so I think that it would be 6 centimeter.
I just pausing it. Can you see and hear the clip?
Yes, yes, sir. We can.
Okay, thank you.
There is 1 centimeter here, 1 centimeter here, and 1 centimeter here, and 1 centimeter here, and 1 centimeter here. If we add all these, then the answer will come 5. Well, actually, it is 5 centimeter, but it is written wrong. It should start from 0. So it becomes 5 centimeter.
Kids start learning how to use the ruler, how to measure length with a ruler. Now, when we tested class 4 children on this concept of measuring length with a ruler, we essentially found 2 kinds of misconceptions. The first one is something that we had kind of foreseen, and maybe even some teachers might foresee, and that is instead of the starting and the ending point of a object while measuring, kids see only the ending point. So if an object ends at, say, 9 here, they consider the length of this object to be 9 centimeters or 9 units, rather than seeing, from here to here what that length is.
This point is touching to a 9, that's why it should be D, 9 centimeters.
Yes.
The pencil is showing 6 centimeters because the 6 centimeters, the point till the point 6 centimeters is matching, that's why.
Okay.
One, two, three, 4, 5, 6, 7.
So you counted that, and that's why you said that
Yeah.
it's 8?
Yeah.
And not because this point is 8?
No. Starting from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This 4 will count as 1, and till 9 it will be 6. This is 1, 2, 3, 4, 5, 6. We will see how much there is. It starts from 6 because it starts from 4, 1, 2, 3, 4, 5, 6. Name is here, and the answer is 6 because it's starting from here. 1, 2, 3, 4, 5, 6. And the ending point is here.
So the second kind of misconception is when they have trouble actually understanding what is it that has to be counted. What is the nature of the parts that have to be
Okay, I'm going to
counted.
skip this a bit because I think you have all got the point. You've seen what the students were answering. And so, okay. So let me go back to the slides, I think, and it's very interesting. Maybe I'll just show you a couple of minutes more of. Okay. So here is another interesting part of the video, which is worth seeing. So let's watch that. What is 1 centimeter?
So is this point 1 centimeter, or is this much 1 centimeter, or is this much 1 centimeter?
I think this point is this to this is 1 centimeter.
This to this is 1 centimeter.
Yeah.
And this to this?
That is 0 centimeter.
This is 0 centimeter. How much is this to this?
2 centimeters.
Okay, so this much is 2 centimeter?
No. Yeah.
Okay, how much is this?
Five centimeters.
Only this much is 5 centimeter? Or you're counting from all the way?
From here to here. But the pencil doesn't start from there. But still, these markings means this is 1 centimeter, this is 2 centimeter, this is 3 centimeter. It ends up till 6, so I feel it's 6.
Okay, so you're saying that because it ends with 6 centimeter, it must be 6 centimeter.
Yeah.
Okay, fine. So show me what is 1 centimeter on the scale.
So this much.
You're putting 2 fingers, so how much exactly? Okay, so you're saying this line to this line. That is 1 centimeter? Is that what you're saying?
Yes, sir.
The child counts it as 1, 2, 3.
Okay, so I'm going to stop sharing because we don't have a lot of time and go back to my slides. Dr. Sebastian, can I take about 5 minutes more?
Yes, sir.
Is that okay? Okay, so we started a bit late, so let me just take, okay. So I think you saw that video and you got a sense of what is really happening, why the students are thinking. They're very confident in the video, but they're thinking very differently from the way we adults think. And let me just dwell a bit on one of the questions. You saw 2 or 3 different kinds of thinking, but I'm just going to pick one. So which is that some students were counting marks instead of inches. And I'm going to ask you the question. Now, if you're actually equally spaced marks on a scale like this, would it not work in order to measure length? Because they're equally spaced and we can always measure length by just counting how many marks, so to speak, fit into that length. And what would happen? What if we adopted this new system? We can actually work with this new system. And so here is the conventional system by which this pencil's length would be 5 centimeter. But in the new system where we are counting the marks, it would be 6 centimeter. So similarly, if you had a length of 12 centimeter, it would be 13 centimeter. If you had 25 centimeter, it would come out as 26. So apologies for the spelling mistakes, 26 centimeter. So we have a new system of measurement, but actually it seems to work. I mean, why can't comparison of lengths would still work? So mathematically speaking, order is preserved. So here is the next poll. So would you therefore say that, would you accept counting marks instead of counting intervals in order to measure length? So what do you think? Can we adopt this system? Because so many children are spontaneously or naturally arriving at it. So can we have this poll? I'm very curious to see what you would say. Okay, so I hope people have clicked. Maybe they're still thinking. So there are the results of the poll. Okay, so that's very interesting. So we have a divided house with just a small, slender majority, like in some of our states. So that's okay. So that's also very interesting to me. And let me just go back to the previous slide, so that so you have actually that we saw that we can compare lengths. The bigger lengths would still be bigger in the new system. The smaller lengths would be smaller. So order is preserved. So we will be able to order lengths. However, what about addition of lengths? Now, you know that 5 centimeter plus 6 centimeters should give you 11 centimeters. Now, 11 centimeters in the new system will correspond to 12 centimeters. But if you did the addition in the new system entirely, so 5 is actually 6 and 6 is actually 7. So if you added them, you would get 13 centimeter and not 12 centimeter. So you see that actually addition of lengths doesn't work. And you can think about multiplication of length by a number, multiplication of two lengths to give area, division of a length by a number because you're partitioning a length into equal parts and so on. And think about whether all of these would work. And you would see that actually in the new system, these things would not work. So which is one reason why we adopt the system that we do, which is actually we are counting the intervals and not the marks that fill up a particular length. So we learned something about measurement by reflecting on why students make particular errors. And one important thing is that the measurement system that we adopt, the conventional one versus the new one, which one do we choose? It should work not only for comparison, but also for operations, such as addition, subtraction, multiplication, etc. And these are very important in measurement because these correspond to the actual real life operations of joining, which is addition, replicating, which is like multiplication, making multiple copies, partitioning, which is to divide a length into equal parts and so on. So all of these should map onto operations we do with numbers, which is the calculations that we do through a simple relation, and it shouldn't be too complicated. So that's my second example. And I think I should stop here. Of course, I would have liked to do a third example, which is of the example of division, which is very fascinating because it's there in the NCERT textbook. But I'll just point you to a reference which you can look up, and it's a fascinating case of students thinking and using students thinking in teaching in the classroom. So let me stop there. Those are the acknowledgements. Thanks to all my colleagues in the mathematics education group at HBCSE. I acknowledge the support of Government of India under this project and the Atomic Energy Department, which is the parent organization for TIFR, which is the funding organization. And thank you. And that's our website. You're welcome to visit it. Apologies for taking longer. And now we are open to questions. So let me stop the sharing.
So thank you, sir, for that talk of yours. And I would request Clarice to take up the questions, and also now if you can help her.
Okay, ma'am, I'll take it. Sir, yes, ma'am. So, sir, we'll begin with a question and answer sessions that the student have asked on Zoom and YouTube. So, sir, the first question is, how will you teach mathematics to a child of 6th grade who is a special child in terms of understanding simple concepts like addition and subtraction and also area of perimeter?
Now that's like a huge question. I think even if I had the expertise, I'm sure one cannot answer this question in a short time. So I just like to point to a lot of work which has been done, not by me, but by many others on working with special children. Just recently, a student of mine completed his dissertation, Rossi D'Souza, on teaching mathematics to the visually disabled. I'd invite you to, he has also published and written papers. Please to refer to them. I'm sorry, I can't answer in more detail because this is like a really involved thing. It's a very important question. and I'd just like to point elsewhere. So let me skip that.
Rachel, any more
Okay.
questions? Yeah.
No, ma'am, that's all. Only some student wanted the third example, but due to we don't have that much of amount of time, so we would not be able to take that example. Just let
Okay,
me check, sir, for 2 minutes. Ma'am, let me check one. Ma'am, there's one question. Which
can I ask
application
one
you used to
question?
test the poll one?
Can you
Sir,
repeat?
can I ask one question?
Yes, ma'am. I think someone is trying to ask questions. So
Yes.
you mute yourself and ask question.
Yeah, okay, okay.
So how did we do the poll? I think that's the question. And actually the expert here is Dr. Sebastian. I just took her help. She set up the poll. Dr. Sebastian, I think it's a feature of Zoom. So would you like to say something very briefly?
Yes. Okay, this is not related to the webinar. I think you can go on the Zoom website and understand about the poll. So if anyone wants to know, you all can text me after the webinar. I can explain. Rachel, any more questions, please?
Yes, ma'am. A last one. How could estimation of division be taught in a easier way?
Okay. Again, I'd refer you to this paper, which is flashed, and I'm sure it will be there on the YouTube recording, which will hopefully work and be made available. So it's very important for students learning mathematics to learn it in a meaningful manner. And one of the important things to do to allow this is to connect your teaching, your problems, and so on with actual contexts. So division is most easily and best connected, whole number division, to the context of equal sharing. So if you've got equal sharing situations and interpret division in terms of equal sharing, then that gives students some idea of how to estimate. If you say, 600 rupees or 648 rupees shared among 4 students, how much would each get? They would know at least that each one gets more than 100 or more than 150 rupees. And so that would give them an ability to estimate. So I think it's very important, and I have written also quite a bit about this, to look at the meaning of mathematical operations, to connect them to actual context, and to present these to students so that they can, they're not just working with symbols, they're not juggling symbols, but they're connecting these symbols to actual meanings, quantities in the real world, and thereby they're making sense. So that would be very helpful in arriving at estimation. Of course, estimation itself can be strengthened in many ways through exercises on estimation. But the most important thing is to connect to meaningful contexts.
Sir, I have a doubt.
Yes, Dr. Samuel.
Yeah, it's not a question, it's just a clarification from your side. Sir, what it means to be a mathematical thinker? Is mathematics thinking different from thinking in other subjects? Because curiosity, observation, imagination, etc. are needed for, is it a requisite for learning other subjects or solving problems in other subjects? So for solving mathematics problems, students use a particular style or a particular fashion, or they are using a procedural knowledge to solve the problems.
That's really an excellent question. And I think it's something that, but thank you for asking that, because I think I should have also addressed that in the talk. So I talked about elements of thinking, taking an example from outside of mathematics, from science. And so your question is very legitimate. So what is it that distinguishes mathematical thinking from other kinds of thinking? And yes, so mathematics, one way of describing mathematics is that it's the science of patterns. So you look at many examples and you try to see what is common to them at an abstract level. So at the level of just patterns. So this is one way of describing it, and it probably doesn't make too much sense unless I give an example. For example, you could take Rubik's Cube, and you see that the mathematics of the Rubik's Cube is something related to what is called groups in algebra. And it's a very abstract idea, but it explains the pattern underlying Rubik's Cube and how the cube gets solved and many other things which are similar to the Rubik's Cube and so on. So this is one aspect which is special to mathematics, which is a kind of abstraction by looking at the patterns and by generalizing the patterns. So these are keywords: generalizing, abstraction. These are keywords. The other part of mathematics is the reasoning which is involved. The reasoning which is involved in mathematics is slightly different from the reasoning in science or in other subjects, where you actually do experiments, carry out further observation, test your hypothesis or your conjecture. In mathematics, that is necessary to some extent. You have to test your conjecture by looking at examples and so on, but that's not enough, because you must arrive at something called proof. So proving is something special to mathematics, deductive proof. So you begin with what are called axioms and definitions, and you reason with them till you establish something to be completely true on the assuming that the axioms and definitions are true. So this is special to mathematics. So proofs, I think. So this, I hope it gives you some bit of an answer, but it's probably needs more explanation. Thank you for that question.
Sir, I have a question.
Yes, doctor.
When you showed the errors that students are making, I was really surprised at the way each student, the students who were making the errors, how they were looking at the same problem. So, sir, can you give some tips, how the school or the teachers can minimize these errors in the students? Why are they looking at it so differently? Like it's just the length of the pencil, but they didn't even know how to measure. So what do you think the teacher should do to eliminate these kind of errors in students?
Yeah, that's a good question, and it probably requires a long answer. So the answer that I tried to give in this talk is a very preliminary but essential step. So let me just repeat that. So as you noticed, children think, it's not that they don't think, and they think very differently from adults. And I think, we are surprised at the way that they think. And you see with such confidence that they're actually expressing themselves. And this is really what constructivism means. And constructivist teaching is pointing to that the first step is to listen to the students' thinking, which we miss most of the time. And in order to listen to the thinking, we have to elicit, to bring that thinking to the surface. And we can bring that thinking to the surface through questioning, through probing, like the person was doing in that video. So you actually try to see what is going on in the student's mind. You first get an idea of it by looking at the pattern of responses that the students have. And then you probe a little more. And when you come to understand, you also try to see what is the rationale, what is the justification behind that thinking, which is what I try to do. I'm not sure whether it's successful, that even counting marks has some justification. But that's not what we do in mathematics. And why is it that we don't do that? So I think teachers need to understand certain choices we have made in mathematics. We're not counting marks, but counting intervals, because it's important for doing operations with measurements, not just comparing lengths, but operating with lengths. So once you're armed with this kind of knowledge, with this power and capacity to notice, now you're ready to begin teaching, which can actually help students to go forward in their thinking, to align with more standard ways of mathematics, to probe, maybe come up with mathematics of their own. So, but how to do that, I think we need more discussion on pedagogy, and so that maybe we can take up another time.
So I think, sir, we need to have a part 2 of your session, because we were really curious to know what you're going to show about division also. So,
sure.
Sir, you will make time for us for one more session, sir, so that we can have some good time with you discussing about the other operations also.
Sure.
So thank you, sir, very much for your valuable time. Over to Sona. Clarice is going to introduce our next speaker. We have Dr. Shweta with us, who will be talking to us about the activities of the Homi Baba Center for Science Education. So, Clarice, I invite you to introduce ma'am.
Good evening, everyone. Very fortunate to introduce our second speaker for the day, Dr. Shweta Nayak. Dr. Shweta Nayak is currently working with Mathematics Education Group at Homi Bhabha Center for Science Education, Mumbai, and was adjunct faculty position with the University of Northern Colorado for the year 2018-19. Ma'am has received a PhD in Mathematics Education from the University of Michigan, USA, Masters in Mathematics from Pune University, and Bachelor's in Mathematics from Mumbai University. Dr. Nayak has diverse teaching and professional experience and has worked with educational institutions and various boards like CBSE, ZIET, St. Xavier's Institute of Education, University of Michigan, Tata Institute of Social Sciences, etc. Ma'am has taught at many levels and pedagogy of mathematics to masters and PhD students. Ma'am has also been one of the active resource for teacher education at HBCSE and has been focusing on teachers' mathematical knowledge required for teaching that facilitates access to mathematics and learning with understanding. Ma'am has won a lot of awards and scholarships and is the writer of numerous books and journals. Ma'am has done a remarkable work in teacher education and experience in mathematics. Words and time will fall short to tell everything about what incredible work Ma'am has done. We are pleased and grateful to have you, Ma'am, with us today. Thank you.
Thank you. Thank you, Clarice.
Welcome, ma'am.
Thank you. Actually, I feel a little bad because the discussion with the case presentation, Subramaniam sir presentation was going on very well. And I see many of the people have commented for sir to continue. So sorry about that.
That is what I told sir that we need one more session.
Yeah. And I think it's challenging to have that kind of a session in an interactive mode. So I think it went very well. So yeah, I also enjoyed it. How much time I have, Vinny ma'am, now?
Yeah, 15-20 minutes, ma'am. Okay. Is it enough?
Okay. Yeah. So I'll share my screen.
Yes.
Can you all see?
Yes, ma'am.
Okay. I can't do the full screen view. Full screen even here. Okay. Hello, can everyone see me and hear me?
Yes.
Yes, ma'am, we can.
So I'm actually not going to talk about much of any ideas or anything. I'm going to talk about some of the activities that the Homi Bhabha Center for Science Education does, specifically the Math Education Group. Professor Subramaniam is the director of the center, and the center has many sections: design and technology, science education, other talent nurture program. And I am going to talk only about the math education. Primary reason for this is that it's very exciting to talk to many of you in such mode, to be with you in like a same space, not physical space, but some sort of an interactive space. So I don't know whether in pandemic also we could figure out some sort of collaborations and post-pandemic too. So I'm just going to explain you some of the things that we do. So this is sort of the things that I'm going to talk about, that what we have in math education. Just make note of two things, that this is the work of many people who have been part of math education group and are part of the math education group right now. That is one thing. And secondly, all that is I'm going to show you in today's slides is available on our various websites. So towards the end, I will post links for all of them in one slide, and you can take a screenshot so that you will have all the links. What I will try to do today is I'll try to tell you what sort of things you can get engaged with us, or what sort of things you can look at our website, and in future, whether we can do any collaborations. So, okay, I will move on. I'll talk about math laboratory first. So maths laboratory is sort of a space that we have at the center. Here is one picture from one sort of a view. It's a small room, accommodates 30 people, but we have kept it on purpose a small room where students or teachers sit, talk and explore. So it's a place to explore some mathematical ideas through games and puzzles. There are many ideas when you say maths laboratory, there are many other ideas that come to people's mind, and many other people are doing something called maths lab. But we do not do something which is for like a assessment, or it's similar to practical of maths where you get some marks from practical and some marks from theory. So this is what we think, that this space is more about trying to explore, do some discovery, things like that. And the materials that Maths Lab has can be used by students as well as by teachers. It is very difficult for me to show you all the materials in this session. Yeah. So what I'm going to do is I'm just going to give you a glimpse of one of the activities from a maths laboratory. So can you see, all of you, can you see the square? Hello?
No, ma'am. We just can see the first screen.
Oh.
The first slide. Yes, now we
Yes,
can.
ma'am. Now we can see.
So let me not do the full screen. So let me go back. Yeah. So these are the 5 things I'm going to, 5 things I'm going to talk about. The first is math laboratory. I think the full screen doesn't show you, so I'm not going to do the full screen. This is a picture of math laboratory. Can you see the picture now?
Yes, ma'am.
Okay, great. I'm glad I asked. And this is the room I mentioned. It's a small room for 30 people. And this is what I said about Maths Lab, that it's not for assessment, but it's more for making interest in bringing interest in students, doing games and puzzles and exploring, discovering few things. So just to give you an idea, I'm going to give you an example, and I'm not going to like explain this, but just leave it as a brain teaser for all of you. Some of you actually might know about this. So all of you can see the square, and what is the area of the square? Everybody knows that. Can somebody just say what is the area of the square?
64.
Yeah, it's 64 square units. Ignore the red lines for a moment and just look at the figure. So it is 64 square units. And like if you see in the like a corner, the red lines that I have shown, if you cut at those lines and rearrange that square, we got this new rectangle. And the rectangle has dimensions now 13 by 5. So what is the new area of this figure? Is actually 65 square units. Is that right?
Oh.
Yeah. So what we just did was we took a square which has area 64 square units, and we now have a rectangle with some cuts which gives you 65 square units. So the question is, can area be changed by cutting? Can area be increased or decreased when you cut something and rearrange it? If you have not lost any paper or not lost any cloth. So does this make sense? So when we do this with students and teachers, we ask them to figure out what is actually happening. With students, it is very interesting because some of the students actually think that when you cut the paper and put it far away, the area is increased. So for them, they think that the area is increased because we cut the paper. Now there are more number of pieces. So there needs to be a different kind of discussion with students. Of course, why this happened, you all might be thinking that what is the reason behind this? So there are 2 ways to look at it. I'm not going to give you answer, but I'm just going to tell you the ways in which you can look at it. One way is you can actually make this square, make these cuts and try to rearrange this and see what is happening. The second way is you have the dimensions in a way for each of the triangle form, number 1 and 2, and each of the quadrilateral form, which is number 3 and 4. So you could actually calculate the slope for the sides which are coming on top of each other and see what is happening there mathematically. So yes, but I'm not going to tell you that why this area is increased. For that, I think if you visit our website, and I will show you how to do that, you will find what's the explanation for this. But the point is, these are the kind of activities that we have, and we have roughly 55 to 60 right now in a written form on the website, and they are in both English and Marathi language. The second component that I said is teacher professional development. So we do engage in teacher professional development at in-service and pre-service level. So, so we do in-house workshops for professional development, or we do collaboration with other institutes. What we have done in the past have focused on content knowledge for teaching. So there was example of that in Professor Subramaniam's talk today, that what does it mean to know mathematics for teaching. So in short, when one says that I know how to do the multiplication, is a content knowledge of multiplication. But I know what kind of different answers students will give for a multiplication problem, and how to talk about those alternative answers or their systematic errors is a content knowledge for teaching. So that is a very specialized knowledge that only teachers, that is our professional knowledge that only we need to have. So we have been focusing on that for in many of our workshops. We have done topic-wise discussion of those. We also want to focus on, we have worked on how can we learn from our own teaching. Because when we become a teacher in service, the time is such a big issue that how can we develop some noticing, learning things that we can learn from our own teaching. That has been also our focus. We love to do problem solving in mathematics. In fact, with St. Xavier's, one of the batch, we have done problem solving in maths with students. And then there have been other talks about policy, how to understand educational theories. So this has been the focus for TPD with the teachers. We have been also working with teacher educators, mostly in collaborations with DIET and SCRT. And we try to focus that what they can notice from the teaching, what are the forms of different lesson study, its enactment, and what is a mathematical knowledge for teaching, what should you look for when you talk to teacher, or when you observe a classroom, things like that. We also have something called teacher fellowship, which I think would interest many of you. It is where a group of teachers or teacher can come and work with us, and teachers can actually develop activities. They can come up with their own questions, like I was teaching this and student responded this, and I want to know how to have this particular trajectory of, say, trigonometry, or how to teach ratios. And we could work out things together. We could actually access what we already have. So that kind of fellowship is possible. And of course, we do some courses for pre-service teachers for B.Ed colleges. I have written HBCSE certificate course there, which is a plan. It's not, it doesn't exist yet, but it has been a plan, and hopefully it will happen sometime. We do courses on pedagogy of mathematics, problem solving in math, understanding education theories, and understanding worldwide research, especially the one especially research that has impacted teaching and teacher knowledge, sort of. Then there is, we also engage ourselves in math education research, like case used example from Shikha's work. Shikha is one of the math education researcher, and she has finished her PhD. So we do student camps, various student camps in summer and winter vacations. We haven't done in recent times because of various reasons, but we have used those summer camps to explore various teaching strategies, to understand what is students' mathematics. And I particularly like this word, that there is a mathematics as a discipline, and then now we are calling some mathematics for teaching. And there is a student math that we need to uncover. So we sometimes do interviews, we talk in length with students. We also develop worksheet teaching sequences and textbooks. The pictures are shown for the primary textbooks here. You will find more worksheets on our website, which I'll give you the link at the end. We also do research in teaching where we collaborate with teachers in a sense that so you can see in this picture, one of my colleague Tuba is recording the class, and I'm sitting in another beside her and taking some notes. And we are observing teaching, so we try to develop some tools for classroom analysis, create video episodes. And this is something I think teachers should take more interest into, even though it looks little foreign in the sense, but I think this is where you can take a big classroom and actually zoom in and see your teaching in a very micro form to understand some of its components, some of the things that are happening, which are very difficult to observe them when you're standing in front of 55 students and teaching. So this is something we do research in, and yeah, if people want to join, collaborate, there are possibilities to do that. Then I'll talk about Vigyan Pratibha units. Sorry, I'm just running very fast because I know people might have other commitments. So Vigyan Pratibha is a project recently started 2 years back, and it is focused at grade 8 and grade 9. But what has what has been developed in these Vigyan Pratibha units is very specific units in mathematics, which sort of bridges the gap of school mathematics with something that might go in advanced mathematics. Not exactly advanced mathematics, but some of the practices that you need to do in you need to do advanced mathematics. For example, when Case was talking about proving, so what sort of things you need when you try to prove something, what it means to do mathematics. Like in science, you have to take observations, but what are some core practices in mathematics? So I think they have been focusing on some of the practices, and there are very interesting units available for free. There are detailed units for grade 8 and 9, and there is a possibility for you to collaboratively teach and design these units there. So that is another option. They have also developed something called learning bites. I think I don't have time to show the video, but what they have is mini videos of mathematics teaching, something that actually teachers can view on their mobile. And the videos are mathematics, about sometime mathematics, which has an implication to instruction. And here also you have possibility for a collaboration. I think Winnie ma'am in the beginning when she said about this 1 minute videos, I thought it's a very fascinating idea. And I actually think that you can capture really good things in even in 1 minute. So I will be looking forward to that YouTube channel, what videos you all send. But in Learning Byte also you have possibility for a collaboration, creating videos, creating content. Then lastly, this is a new association that it's not part of HBCSE, but it's an affiliated sort of a thing. Many of us part of Mathematics Teachers Association. You can become a member and be part of these activities. Right now, there is not much of the activity happening in Maths Teachers Association, other than they have a bulletin. We have a bulletin which comes sort of once 5 to 6 months. But the thing is, this association has an integrated sort of a membership. So you have teachers from college, you have teachers from school, you have primary teachers. So when we had one conference within this association, it was very interesting kind of a dialogue. So for that purpose, I think it's a good platform to join in and be part of the activities. So this is the slide which I mentioned that you should take a screenshot of. The first link is the Homi Bhabha Centers link. The second link is Mathematics Education HBCSE link. Third link is where you will find all the learning units that I mentioned for grade 8 and 9. And the videos that I mentioned, mini videos that you'll find on Vigyan Pratibha. And the last one is the Teachers Association. The second link, Math Edu HBCSE, has again many sub-parts into it. The link will look like this. When you open the website will look like this. And there will be many other things that you can access. So you can access some of the videos of teaching. You will have access to posters that we have designed. You will have access to all the mathematics laboratory activities. You'll have access to books. So we have been following that whatever we have been creating, we are making it available in an open access mode. Maybe we are a little bit behind in uploading everything, but most of the things are there. This is sort of a team, and you'll find this is some part of the team. Of course, there are many teachers and other people who have been with us. You'll find more details about each of them at the website, this website that I just showed you. Okay. Now I just want to make a suggestion that if you have anything, any of this activity, you feel like it matches with your wavelength, you want to explore more, you can write to us. My only suggestion would be, before writing to any of this email ID, I would suggest that you please visit these websites, explore them very well. Because see, it is very overwhelming that if you have a general interest, so its processing is difficult. I think if you can find out something very specific that is useful for you, suitable for you, and maybe possible in pandemic, post-pandemic, then please write to us. So that is all I have. Thank you very much. I think I finished fast, so that should save some time. And yes, I want to thank you, Vinny ma'am, just to have this experience of meeting so many people at the same time. And thank you, St. Xavier's. Thank
You're
you, Samuel.
welcome, ma'am. It's our pleasure.
Yeah. So how do I stop sharing? Yeah.
Yes, ma'am, on top. Yes.
Yeah.
So, ma'am, I think, due to lack of time, I'm not taking up any questions. You have already given the email ID and also they can contact you. And definitely our institution will definitely collaborate with you, and we'll see next year how we can take it from here. Thank you very much for presenting all the activities, ma'am.
Thank you.
So I request Risal now to propose the vote of thanks. Risal.
Yes, ma'am. So on behalf of St. Xavier's Institute of Education, Manager Father Blaise D'Souza, Principal Dr. Susama Samuel, and Mathematics Pedagogy Staff in charge, Dr. Vinny Sebastian, I would like to extend a heartfelt thanks to our resource person, Dr. Subramaniam, who has enlightened us all with an amazing session today on the topic. A prerequisite for constructivist teaching is listening to students' thinking. Thank you, sir, for accepting our invitation for this webinar readily, and we are really grateful to you for sharing your knowledge and thoughts with us today. I am sure that all our participants have gained some amazing insights on how to improve mathematics teaching. As it is rightly said, teaching is a listening profession. Sir, you have made us realize how important it is to listen to students' thinking in order to find out the root cause of misconception that students might have in their mind regarding various concepts in mathematics. Right from explaining various examples to showing an actual demo conducted in classroom, you have made this session so interesting that everyone wanted to hear more. I would also like to thank Dr. Shweta Naik for letting us know about various activities conducted by Mathematics Department of Homi Bhabha Center for Science Education for enrichment and development of teachers and students. In the subsession, ma'am has elaborated various activities that are really beneficial for students and teachers both for developing a profound understanding of mathematical knowledge required for teaching, finding places for students' ideas, and making mathematics learning more practical and fun. I am sure that many students, teachers, and institutions at large would be interested to participate and experience these workshops. So thank you once again to both the resource persons for today. We couldn't have asked for more better ones. Next, I would specially like to thank and appreciate our staff in charge of Mathematics Pedagogy Unit, Dr. Vinny Sebastian, for coming up with this wonderful idea of having an online math webinar series in this current COVID situation. Thank you, ma'am, for your support and encouragement. My heartfelt gratitude to our student coordinators, Ms. Alsona Gomes, Ms. Rizal Gonsalves, Ms. Clarice Lemos, and Ms. Rachel Carvalho for being the strong team behind the curtain and providing technical support. Arranging an online platform for such a large audience was made successful by the hard work put in by each and every one. And last but not the least, A big thank you to all the participants for your presence. Without each and every one of you on Zoom and YouTube, this event wouldn't be successful. We hope that you are taking back something with you from this today's session and that you will make use of it in your respective field. So once again, thank you for making this event successful with your enthusiastic participation. With this, I end my vote of thanks.
Okay, so Alsona, can you give some instructions regarding the feedback?
Yes, ma'am, I will continue.
Yeah, Risa.
Yeah. So, participants, a few instructions regarding your certificates. Firstly, note that submitting the feedback form is compulsory in order to receive your e-certificate. Feedback links will be posted in the WhatsApp group soon after this session ends. Also remember that the links will be active for just 1 hour, that is up to 7 p.m. as informed earlier. Kindly fill the feedback form with correct details as no changes in name would be done later. Your certificate will be mailed to you within 30 minutes after submitting the feedback form. In case of any queries regarding certificates not received, please write to us within 1 hour, beyond which no doubts would be considered. Thank you so much.
Thank you, everyone. I'm signing off for the day and see you for the next webinar series. And please remember to send your 1-minute video. We are waiting to receive the video and share the innovative ideas with you. Thank you, everyone. Bye.
Thank you, ma'am.
So I'm ending the meeting for all.
Yes, ma'am.